Hello friends, very good morning to all of you. So we came to the part 7, that is the end of PF54, that is the OAuth common client vulnerability section. So in this section we'll talk about native application best practices. So what is the best practice for making that authorization framework for native application, how we can go for an authorization, which grant and how the configuration should be, so that it can be secure and safe, right? So we'll just try to understand about the best practice of the native application. We talked about earlier also in our previous session, but yeah, in this session again we'll talk, maybe it can be a revision for us. Okay, so that is PF54 part 7, and with this, like, we'll complete the PF54 section, that is the OAuth common client vulnerabilities. And now we'll move to OAuth common protected resource vulnerabilities, and then we have some parts for that also. So it's basically the session I'm just taking, like here, like OAuth common client vulnerabilities, and we have the common protected resource vulnerabilities. Like that, we have some more. So it will be around like 15 16 sessions where we can just talk about all those things, like how what are the thefts of this, like token part or the code part, how we can protect, how we can make it safe. We'll just talk about these topics. Okay, so let's begin and we can talk. Okay, so let's discuss VF54, the last part 7, that is native application best practices. I think we already have some idea that for native application nowadays we are going with the PKC flow. But yeah, let's quickly discuss on this. So we have seen that native applications are OAuth clients that run directly on the end user's device, which these days usually means a mobile platform. Historically, one of the weaknesses of OAuth was a poor end user experience on mobile devices. To help smooth the user experience, it was common for native OAuth clients to leverage a web view component when sending the user to authorization server endpoint, interacting basically with the front channel. A web view is a system component that allow application to display web content within the UI of an application. The view act as an embedded user agent separate from the system browser. Okay, it's not a browser, you can say. Unfortunately, the web view has a long history of security vulnerabilities. Most notably, the client applications can inspect the contents of the web view component and would therefore be able to eavesdrop on the end user credentials when they authenticated to the authorization server. Since a major focus of OAuth Yeah. Since a major focus of OAuth is keeping the user's credentials out of the hands of the client applications entirely, this is counterproductive. The usability of the WebView component is far from ideal because it is embedded inside the application itself. The WebView does not have access to the system browser cookie, memory, or session information. Accordingly, the WebView does not have access to any existing authentication sessions, forcing user to sign in multiple times. Okay, that means again need to log in, always give ID and password. Native OAuth clients can make HTTP requests exclusively through external user agents such as a system browser. A great advantage of using a system browser is that the resource owner is able to see the URI address bar, which act as a great anti-phishing defense. It also helps train users to put their credentials only into trusted websites and not into any application that asks for them. In recent mobile operating systems, a third option has been added that combines the best of both of these approaches. In this mode, a special WebView style component is made available to the application developer. This component can be embedded within the application as in a traditional WebView. However, this new component shares the same security model as the system browser itself, allowing a single sign-on user experiences. Furthermore, it is not been able to inspect by the hosted application, leading to greater security separation on par with using an external system browser. In order to capture this and other security and usability issues that are unique to native applications, the OAuth group is working on a new document called OAuth 2 for native apps. Other recommendations listed in the document include the following: like for custom redirect URI scheme, pick a scheme that is globally unique and which you can assert ownership over. One way of doing this is to use reverse DNS notation, as we have done in an example. In our example application, that is com.auth something.mynative app. This approach is a good way to avoid clashing with the schemes used by other applications that could lead to a potential authorization code interception attack. So I think we already seen this, right? Using this URL handler, this is been used in the redirect URI, that com.auth.mynative app. In order to mitigate some of the risk associated with the authorization code interception attack, it's a good idea to use PKC, proof key for code exchange. The simple considerations can substantially improve the security and usability of native application that use OAuth. So I think there is already discussion research is going on this native for native apps, but for now, if you want to implement any like OAuth SSO for your native app, then go for this PKC, proof key for code exchange. Okay, that's the best practice. Let's check the summary part what we have covered in this OAuth client vulnerability. So OAuth is a well-designed protocol, but to avoid security pitfalls and common mistakes, the implementer needs to understand all its details. Maybe tools are doing, but at least as an engineering person, you need to understand. In this common client vulnerabilities topic, we have seen how it is relatively easy to steal an authorization code or a token from an OAuth client that did not pay attention to registering its redirect URI. That is the most important thing what we understand in this complete 506 session. In some situation, the attacker is also able to maliciously trade the stolen authorization code with an access token or to perform a sort of CSRF attack using the authorization code. And to avoid it, we can just pass a state parameter as we have seen in the CSRF attack. Use the state parameter as suggested in the specification, even it is not mandatory also. Understand and carefully choose the correct grant flow for your application. Native applications should not use the implicit flow as it is intended for in-browser clients. Native clients cannot protect a client secret unless it is configured at runtime as in the dynamic registration case. So that's a risk like for native clients to use that auth code flow where you have the client secret. The registered redirect URI must be as specific as it can be. Very important line. Do not pass the access token as a URI parameter if you can avoid it. You have a way to pass the URI access token as a URI parameter to call some API, but you need to avoid it. You need to go for the same method what we have seen, that passing the token in the authorization header. Okay, now that we have locked down our clients, let's take a look at few of the ways that we can protect our protected resources. So we just talk here for the client part. Now we'll just try to look on the resource part also, like what vulnerabilities can come there also and how we can avoid it. And same thing we can talk about the token side also, about the BRR token side. So in this 5 or 6 session, we talked mainly on the client side, right? And we see that how the redirect URI is important, CSRF attack, open redirect vulnerability, referrer part, right? So all these things we understand. So I hope you understand and get these things. So these things maybe you can get from any of the tool is doing all those scans if you're just making your system, checking your system vulnerability. But yeah, it's good to understand the things. If you get a chance to design something, you have those understanding and you can just put those right while designing the solutions. Okay, if you have anything, please put in the comment section. And also for this all slides, PPTs, you can just get in my repository. I'll just put in the description also. You can go to GitHub and just check that. And if you have anything, yeah, please put in the comment section so we can discuss again. Thank you.